Hello, everybody. Welcome to our number 18 of the virtual classroom seminars. Today's topic, cross-platform migrations, transportable table spaces to the extreme. We will cover a lot of deep dive technology topics today, all about large migrations, complex migrations, where you will use transportable table spaces. And we have some very cool surprises for you, some new techniques, lots of learnings, best practices and such. So for the next 2 hours, we will guide you. And with me today is our boss, our Vice President for Database Upgrades, Utilities and Patching, Roy Swanger. Roy works from the East Coast of the United States, from the New England Development Center of Oracle in Nashua. Then myself, Mike Dietrich. I work out of the Munich area here in Germany. With me is also Daniel Overby Hansen from our team. So Daniel works from Denmark in the Copenhagen area. Then we have Rodrigo Jorge. So Rodrigo works from the beautiful place of Rio de Janeiro in Brazil. And we are very happy to have another guy from Brazil in our team. Alex Zabala joined us recently, but Alex works out from the US, from the Dallas area in Texas. We would like to guide you today. And let me also point out that if you need more information, more background information, you find it typically on our blogs. So mikedietrich.de.com, my blog, Daniel's blog, dohdatabase.com, Rodrigo's blog, dbarj.com.br, and Alex has a new blog as well, alexabala.com. So you find slides and much, much more about the technical topics we talk about today on our blogs. Then you may wonder, when I say slides, do we get access to the slides? Of course. We have them stored in our blogs. You find them, for instance, on mikedietrich.de.com/slides and also on the blogs of everybody in the team. And then we would like to guide you to our next virtual classroom seminar. If you like what you saw today and you want to go a step further towards Oracle Database 23c, in May, to be exact, on May 16, 2 hours earlier than this seminar today, we will guide you to move to Oracle Database 23c and give you also a deep dive into Oracle multi-tenant, because 23c supports only the CDB architecture. And so we will give you a lot of tips and tricks around the move to 23c. If you are still think you need more, we have over 30 hours of virtual classroom seminars recorded over the last years, and you all find them on mikedietrich.de.com/videos. Feel free to access them at any time. So your choice. You don't have to follow the full seminar. If you're interested just on specific topics, follow the link. And in the description below the YouTube video, you will find all the chapters. So you can access each of the chapters you're interested in directly. And when you click on the pictures, you get also access to the slides. Today's seminar is recorded and will be made available approximately a week after we broadcast it today. And this brings me now to the starting point. So, Roy, it's your turn. You will start with an introduction today.
Well, now that Mike has introduced the team, let me introduce the concepts of cross-platform, cross-endian migration. First, let's cover some acronyms. xTTS means cross-platform transportable tablespaces, and FTEX is a version of that for full transportable export and import. And we'll get into what those different acronyms and abbreviations mean as we go along. Typically, cross-platform transportable tablespaces is used for migrating entire databases cross-platform or indeed cross-endian. It can be used to migrate an individual tablespace data file here and there, but normally it's used for a full database to go cross-endian. So I've used that term cross-endian twice now. What does it mean? Well, the concept of endianness is tied to both your CPU architecture and your operating system. And what it means is that the combination of those two things can represent data differently depending on that combination of architecture and operating system. In a big endian system, the high order bytes in a segment of data, for example, are conceptually on the left, similar to how we in the West would write numbers, for example, with the tens digit to the left of the ones digit. But on a little endian system, the high order byte is on the right, which is the reverse, obviously, of a big endian system. This means that the data in your data files or parts of that data might be represented differently on one operating system or another. And that means that if you're going to migrate from a big endian platform, say AIX or Solaris or HBUX, over to a little endian platform such as Windows or Linux, there's some conversion of the data files needed when we do that. You can't just take a data file from a big endian system and put it in place on a little endian system and start running it, or vice versa. Now, there's a specific reason we're talking about this right now, and that is that the Spark supercluster hardware support expires at the end of June 2024, which is this year, during which we're recording this webinar. And that means that all of those supercluster customers are looking for their next platform or next server to migrate to, and a lot of them will be migrating from supercluster to Exadata, which means a big endian to little endian migration. You might have a platform, any one of these platforms in the list, and you may not know which endianness you have, big endian or little endian, just based on the operating system. For example, Linux on Z series or PowerPC is actually big endian, whereas on x86 or ARM, it's a little endian platform. On the other hand, you can have the same processor, such as an Itanium, which is big endian running HPUX or little endian running Linux or OpenVMS. So if you want to query the $V transportable platform view, you can tell what endianness you are on and what endianness you might be moving to. The most common migrations we're seeing now for the cross-platform transportable tablespace method are from big endian platforms like AIX, HPUX, and Solaris, going towards Linux in particular, which is that little endian platform, x86 Linux, whether it's AMD chips, Intel chips, or even ARM architecture. All of those are little endian platform. So that's why you might be interested in this technique. Now that I've covered the topic of endianness, I'll hand you off to Mike to cover more of the concepts of transportable tablespaces as a migration technique. So Mike, take it away.
Thank you, Roy. Let's go on with the concept of transportable tablespaces. You have a relational Oracle database, so your data is organized in tables. It's stored in rows, but you have also potentially metadata in your database. Now, the rows get updated with insert updates, deletes, while metadata gets accumulated when you grant something or you create a view or you create a package. When we discuss now transportable tablespaces or full transportable export-import, we can move everything in rows, your actual data, which is stored in data table spaces, by copying the data files. While for the metadata, which is stored in system and sysaux, but mostly in the system table space, and system and sysaux can't be taken read-only, so we need to find a way, and we use here data pump to recreate that information in your target database. We need a consistent copy of the files. And in order to get a consistent copy of the files, we need to set the table spaces read-only. This can be sometimes a bit crucial during testing, but we come to this later. Then when we copy the data files, we can do a simple file system copy, but this is quite unlikely these days, especially when we deal with large databases. So it's more likely that we deal with backup, restore, and recover. And in order to ease that backup, restore, recover process, we offered you for a longer while Perl scripts. Some of you may know and may have used them already. The last incarnation is the V4 Perl scripts. And many of you have used them. We have used them in several migrations. But at a certain point, you hit a limit or several limits with these Perl scripts. There is no support for multi-section backups. There is no support for going cross-NDNS. So table spaces created on Spark can't be restored and converted to Linux or Exadata, for instance. Then we deal with an inefficient parallelism, and finally, going into several PDBs in a target was not supported either. So it was time to do a cut. And this is an integral part of today's seminar. We introduced today the new M5 scripts. M5 is a new incarnation. It's not based in Perl. This is also why we changed the character now. It's not V5, it's M5 for migration. So it's the new version of the migration scripts. And Daniel and Rodrigo will guide you through the M5 scripts and all the details, how to use them, what exactly are they doing, and how to configure that later in the seminar. The important part is metadata then gets still recreated with data pump. So how do we do that? First of all, you could do transportable tablespaces in the traditional way. So transportable tablespaces mean you take care on all the metadata by yourself. So you either write scripts and say, okay, get DDL with DBMS metadata, create my views and so on. But as soon as you deal with passwords like database links, password protected, you need data pump anyway. So you basically rebuild the stuff in your own logic one after another. This worked for a long while. It still works. You can still use that. It requires 10G when you deal with data pump, or when you go the full script approach and not cross NDNS, then you could even do this since 8i. But it's error prone, it's complex, it's a lot of work. And this is why we introduced with 12c, a long while ago, full transportable export import with data pump. Now data pump is doing all the work for you. Not only plugging the table spaces, but rebuilding all the metadata, because data pump knows how to rebuild it in the right order. And as a secret goodie, we added the support as a source database 11.203 and 11.204. So the old data pump clients knew already about that. This is what we strongly recommend. And in this seminar, when we speak about transportable table spaces, all of us, we always mean full transportable export import. We have no time for all the manual things. We go with full transportable export import, which is available since 12c. The next generation of the M5 scripts, that is what we use here. And it uses or utilizes Armin functionality, which gets embedded to interact with the scripts. And it also eases the full transportable export import migration. So you don't have to be a data pump geek to use that. The scripts do that for you. Take note of this MOS node. It has a very nice number, and you get always the newest version of the M5 scripts from this MOS node. Now let us look closer at the concept. How does this full transportable export import with the M5 scripts work? What do they do? What is the special thing? So in this example here, we migrate from a non-CDB 19C to a PDB 23C, but it could be also a non-CDB 19C, or it could be already a PDB. It doesn't matter for the setup. We use that example here. And first step is our source database, system and sysaux tablespace, of course, users and data table spaces, but a different NDNS format than our target. This is where the concept comes in now. We create a new PDB. It has a system and a sysaux, but no data table spaces. Now, first thing is we take a level 0 backup. That's an image file copy backup, size of your database approximately. And your application, this is important, is still working and operating while we take that. And no matter how long it takes, and no matter how long it takes to convert and restore, we don't care. Important is, even though it's restored into the target location, it's not plugged in. The table spaces are not plugged in yet. We go on, we create now level 1 incremental backups. And again, they get moved over to our target platform. They get restored and merged into the existing level 0. And we can repeat this task. The idea is we increase the frequency of level 1 backups, and by increasing the frequency, we decrease their size and also the duration it takes to copy them and to restore and merge them. Now it's downtime time. We stop the application, nobody can connect anymore. We set the table spaces read-only. Now we want a consistent state. We take the final level 1 backup, we move it, we restore it, conversion is included here, and it gets recovered automatically into the existing ones. And at this point, now data pump becomes our best friend, because data pump full transportable export import now plugs in the table spaces for us, and then in addition does all the metadata work. So users, tables, whatever is needed, triggers PL SQL, data pump rebuilds this in the right order. It knows how to do that. And this is the concept. At the end of the day, please don't forget to shut down your source database. You don't want to have changes there anymore. Direct your listeners and everything to the new environment, and then you go on. This enables you to migrate to a higher database release, to migrate between non-CDBs and PDBs, cross-endian and same endian migrations, and cross-platform and same platform. So it's a universal concept, and it's really meant for very large database migrations. And with that, I think Alex should tell you now a bit more about the requirements. Alex, it's your turn now.
Thanks, Mike. So let's talk about some requirements. So the first one, the target database must have the same or higher compatible parameter set. Another thing, the database must use the same character set. Well, there are some exceptions on it. You can go to the documentation and check, but our recommendation is to use the same character set. To check your character set, select start from NLS database parameter. If you need to do a conversion, we recommend you to do this on the source database, convert to Unicode, and you can use DMU to help on this task. If you are going to a multi-tenant architecture, you can use a different character set on the CDB and on the PDB. For example, you have your production CDB on AL32 UTF-8, and you need a PDB on a different character set. You can provision a temporary CDB with the desired character set, create a new empty PDB in this temporary CDB. Then you clone the custom PDB to the production CDB. Another recommendation is using the same time zone file version in the target database. So to check this version, select start from $time zone file. And as I said, the target time zone file version must be equal or higher than the source. Timestamp with time zone. So if you have this data type on your database and the time zone file version does not match, if you are doing a full transportable export import, the data pump updates this data during the import. So you need to increase your downtime window. And if you are using the traditional transportable jobs, the data pumps will skip the entire table and you need to perform a regular import after the migration. By default, the DBCA will pick the newest available time zone file in the Oracle home. If you need to change this, we have this environment variable or a TZ file you can set to a specific time zone file version, and then you can run the DBCA. If you have timestamp with local time zone, you must use the same database time zone. So this is a different thing. So Before, we were talking about the time zone file version, and now we are talking about database time zone. So to check the database time zone, select DB time zone from $v instance. These are the functions that affects the database time zone. They are not common in application. It's more common to have sysdate and systimestamp, and these two do not rely on the database time zone. So it's determined by database, by the operating system time zone and clock. And also in the multi-tenant architecture, you can have the CDB in one time zone and the PDB in another time zone. Timestamp with local time zone. If you have this and the DB time zone does not match, data pump will skip the entire table on import, and you need to perform a regular import after the migration. Daniel, it's your turn now.
Thanks, Alex, for going over the requirements. Hopefully, you now know that you can migrate your database with transportable tablespaces. So let's take a deeper look at the M5 procedure. Hello, Jony.
Hey, Danny, how are you doing today?
I'm fine, thanks. Could you start off by telling a little about yourself?
Yeah, my name is Jony Safi. I work on the Exadata, MAA, and ZDLRA and Cloud MAA best practices team. Our team, part of development, focuses on building and providing the MAA best practices.
You were one of the masterminds behind this new migration method. Could you shed a little light about why we needed a new method?
Well, everything in life evolves, and we have been using the V4 node for almost 20 plus years, which also my team wrote. And now with the evolution of RMAN and data pump and the increase of the size of customers' databases, we wanted to leverage RMAN features like multi-section size with cross-endian migrations. We want to leverage also pluggable database migration. We wanted to leverage migration from standby. So the idea came, okay, well, let's refresh this node with this new called M5, M for migration, and we kept the numbering 5, to offer the customers a better and more transparent way for migrating from legacy operating systems and hardware to Linux or cloud.
Okay, so what is the new fancy thing behind the M5 script?
The new fancy thing, the magic word behind the script is restore foreign data file. So with RMAN, we built an ecosystem around, if you want to call it a wrapper, around the commands itself, whereby we will take a backup of the database level 0, level 1, up to when the customer wants to cut off. And we take an export data pump. It's very important to mention that we use full transportable table spaces. So this in conjunction, we put the best of the two worlds from RMAN and data pump to ensure a smooth and very well built migration process for the customers. So based on the restore foreign data file, the customer can restore as many times as he backs up. And at the final cutoff, they will take the final backup, which does the export for them. And they will do the import to plug in their table spaces at the destination.
Okay, so since this is relying on new functionality, is there a requirement to version and patch levels?
Definitely. This procedure has been tested and built on top of 1918 and onwards. So customers should be on 1918 and onwards. We have tested this procedure with two very large customers. We're talking about triple digits terabyte databases, one with ZDLRA and one with NFS, and it worked fine for them. And definitely we have to be on the latest data pump bundle patch, as well as the RMAN required fixes depending on the flavor for the customer migration. We have fixes for data guard, if using data guard as a standby for migration source, and if using TDE, something I forgot to mention, that we support TDE as well in the this new methodology.
Okay, that sounds great. Personally, I can't wait to try out this new procedure with our customers. Thank you for taking the time to explain, Jony. Thank you so much. In the interview, Jony mentions that we are using standard RMAN functionality. One of the advantages of the M5 procedure is that the backup and restore scripts are available on disk. You can have a look and see what we are actually doing. If you look in the backup scripts, you can see that all it does is a simple backup tablespace. You can then customize with number of channels and section size and so forth, but it is just a backup tablespace. If we look at the restore scripts, things are a little different, and this is where we use one of those new shiny features. Restore all foreign data files. This is the secret sauce in the M5 procedure. This is a command that we introduced in 18C and greatly enhanced in 19C, and this does all the trick for us during the migration. It is a very smart command. You simply pass all the backup sets that you have. RMAN will investigate the backup sets and determine whether a restore, convert of the data file, or recovery is needed. Compared to the previous migration method, the version 4 Perl script, the new M5 procedure has several advantages. We can now fully support encrypted databases, and for those very big databases that are using big file tablespaces, it is a great win that we can do multi-section backups, so many RMAN channels can work together on the same big file data file. Also, we can use compressed backup sets, which can really minimize the size of the RMAN backups, which is really useful if you need to go to a remote data center. Compressing backup sets does, however, require a license for the advanced compression option. And we made several other enhancements, which makes the M5 procedure superior to what we had before. But since we are using new shiny functionality, there is a requirement for the source and target database. They must be on 19.18 or higher with the data pump bundle patch installed. This is a strict requirement that your database must meet. If you have an older database, you must either patch or upgrade or use the former xTTS version 4 Perl scripts. To make it easy on the target side, the script relies on Oracle managed files. If you're using ASM, this is not a problem. But for databases that uses a regular file system, you must ensure that you set db create file dest to somewhere where the database can create files for you. I've prepared a little demo where we can see the script in action. I have a source database called UP19. It's a non-CDB. I want to migrate it into a container database and rename the database to PDB1. For ease of use, I have a shared NFS mount point, which both servers have access to. I store the scripts and the RMAN backups on that share. Let's see how it works. I'm connected to the source database, and this is the shared NFS mount point. We can see here the M5 driver scripts. But first, let's go into the CMD directory where we have two files. There's a properties file and a tablespace file. I'll start by connecting to the source database. And first, I enable blockchains tracking so my incremental backups will be lightning fast. Then I generate a comma-separated list of all the tablespaces in my database, excluding system and sysocs and all the undo and temporary tablespaces. I take the comma-separated list of tablespaces and put it into my tablespace file. Now we can look at the properties file. Here I tell the script which database to migrate. There's information about the source database, Oracle Home, SID, and such. Also information on how I want to run the data pump export. Some methods to configure RMAN, like number of channels and section size. And if I use recovery appliance, there are some more advanced features. I'll leave them blank for now. Let's start by making the first initial level 0 backup. I call the driver script with L0. It'll start RMAN and create the backup. I can see that the backup scanned 5 GB, that's my entire database, and since it is a level 0, it also outputted more or less the same. It's a full backup, makes sense. In a subdirectory, I can see the backup sets that were created by RMAN. Now I switch to the target host, and I have access to the same NFS mount point. I connect to the container database and create a new PDB called PDB1. The driver script, when it did the backup, created a restore script that I can use on the target to restore the data files. I can have a look, and here we can see the restore all foreign data file commands and a list of all the backup sets that were created by the backup script. So now I can just call RMAN, connect to the PDB that I just created, and specify the restore script. And now the magic happened. The command will examine the backup sets and do whatever it needs to do. It's a good idea afterwards to look at the log file from the operation. I can do a simple grab and see if I can find warn or error in the log file. No occurrences, all looks good. Now back on the source system, I'll do a level 1 incremental backup. I simply specify L1 to tell the script that I want to do level 1 backup. I can see here, because of blockchain's tracking, that I'm scanning far less and outputting far less because I'm using blockchain's tracking and it is a level 1 backup. Again, there is a new restore script generated that I can use. Let's have a look. It looks more or less the same, still restore all foreign data files command and a new set of backup sets. Again, I use RMAN, connect to the PDB and specify the new restore script. And then we can have a look in the log file. All looks good, no errors. Now I switch to the source side. I'll connect to the database. My app schema has a few tables, and I'm going to create a copy of one of the table so we can see that all data is brought along into the target database. We call it history 2. Now I'll start the final level 1 incremental backup. I need to specify the system password so the script can set the tablespaces in read-only mode. After that, the final level 1 backup begins. And then we can do the data pump transportable export. That's it. And I can see that the RMAN backup did scan more bytes and output more bytes because I created a copy of the table, but still far less than the complete side of the database. Now I can shut down the source. We don't need it anymore. On the target, I can see a new restore script, L1F. It's the level 1 final. I start RMAN, connect to the PDB, and use the restore script. This will recover the data files up to the last point. Again, I check the log files. All looks good. Now I'll connect to my PDB and I find the directory path of the directory object datapump.dir. I need to put my datapump dump file into this directory so datapump can import from it. There's also an import driver script that I can use. I need to fill in a little information in the import driver script about my target database, Oracle Home SID, and a connect string directly into the PDB. And I can see that the import driver script, one of the parameters is the last restore log. So let me find that. And then I can call the import driver script. I specify my data pump dump file. I specify the last rman restore log file, and I start in test mode. This will generate a parameter file for data pump that I can investigate for correctness. I can see that everything has been filled. The script scanned the restore log, found all the data files, and added those into the transport data file parameter in the parameter file. So now I can switch from test mode to run mode to actually execute the commands. First, the script will create a guaranteed restore point in my target database, and then it'll proceed with the data pump transportable import. When it completes, you need to scan the data pump log file to see if there are any issues that prevents you from continuing. But for now, I'm just going to connect to the target database. I can see all my table spaces are available and online. My schemas are there. And in the app schema, I can find the history 2 table, which was the copy I created. I can verify that all data has been brought along. This is how you use the M5 script to do a migration, but let's dig a little deeper into the details. Rodrigo, will you take it from here?
Thank you, Daniel. And by the way, this interview with Jony was really cool. Now let's take a look how is the M5 script workflow. So the first step is to configure it. So first you download it from this Moz node, and we recommend you to set up an NFS shard system. Why that? Because that way you don't need to keep copying files from your source server to your target servers. With an NFS, the script will put the files on the NFS, and the target server can read it straight from the NFS. So you don't need to keep moving things manually. After you configure the NFS, but again, this is optional, you need to put the tablespace list that you want to consider in this migration in this dbmid.ts list.txt file. And finally, the property files. These property files, you put all the settings for this M5 script execution. Now, the last step is to create a new empty tar database where you're going to move your source system to. Next slide, level 0 backup. So now it's time to take your first level 0 backup. This is a full database backup. You run that in your source system. How you run that? You call the migration driver script with this L0 option at the end. So the script will create all the backup sets for this level 0, and also this restore script, restore L0 something.command. This is the script you need to execute in your destination server in order to restore that backups there, okay? It's always important to check the logs after you run the backup and also after you run the restore. Now the incremental level ones, and you repeat them as often as you desire. So the incremental L1s will be just the delta since the last backup, and how you run that, again, using the driver script with this L1 option at the end. So what the script will do is create the L1 backup sets, put that on the NFS shared mount point, and also create for you the restore L1 command that you need to run and execute on the destination server in order to restore those level ones. So every time you take a backup, L1 backup, you also need to restore those L1 backups in the destination server. Now is your migration window. You need to disconnect your application and run the final L1. How you run the final L1? Using this third option. So we saw the option L0, the option L1, and now we have the option L1F to provide to the driver script. When you provide L1F to the driver script and call it, it will put your source table spaces in read only. So when the source table spaces go to read only, that's when the real outage comes, because now the applications, they cannot change your data anymore in your source system. This will also run a full data pump transportable export. and put all those files in that NFS shard mounting point, okay? So optionally, we recommend you to shut down your source database. So that way you avoid people connecting accidentally on the system after you do the migration. Now it's time to run the final restore. Again, the script that executed the final level 1 backup will also create a final level 1 restore script. So you get that script, restore l1f.command, you move it, or if it's in the shared mounting point on the NFS, you don't need to move anywhere. You simply call it on your destination server, and this will perform the final recovery of your data files there. Finally, it's the import time, right? So how you run the import. We also have another driver, the impdp.sh. You see that .sh, that's because that's a shell script, that's a driver. You provide some parameters to this driver, and this will create the impdp command for you. If you provide the test as a parameter, it will not run anything, just give you the command that you need to run afterwards in your system. Or you can provide this run parameter. When you provide this run parameter, then it's gonna really execute the impdp for you. And as always, we recommend you to check the data pump log files for any error. If any error occurs, you can fix it, or you can go back to the restore point. By the way, this script, this impdp.sh, it's gonna create a restore point for you. So if any problem happens on your target system, you can go back to that restore point, so you don't need to recreate your full database again, okay? So again, it's important to check the log files to see if any error occurred. All right, so recommendations. First of all, as I already mentioned multiple times, use a shared NFS mounting point. This will make your life much easier because you don't need to keep copying files from your source to your destination server. Okay, if not possible, we can also, this script accepts a manual way for copying and handling files, or you can use also zero data loss recovery appliance. You can use this parameter, but Alex will talk later about that. All right, as I mentioned, the impdp.sh, it creates a restore point for you. So if any error happens, you don't need to recreate your target database. But you need to don't forget to drop this restore point after you finish your migration. Otherwise, this restore point will keep growing, and this may cause some performance issues in your destination server. Also, if it happens to add, or if you want to add any new table space during the migration, you need to do that by adding the table space name on the dbmic ts list.x file. If you don't do that, in your final import, you will see a problem that this table space is not included in the backup sets. So it's very important to include a new table space in that file if it happens of some user to create one, or if you want to include a new one. It's also important to keep the backups that you take during the migration, the level 0, the level 1, and level 1 final. Keep them on your source system until you finish your full migration and you are sure you don't need them anymore. And why? Because those backups, they are cataloged on the RMAN. So if you try to use any RMAN command on your source database, RMAN will see those backups are cataloged. And imagine if it happens that you delete those files using OS commands, then you need to do some cleanup in RMAN, like a cross-check, because RMAN will not be able to find them. So it's very important to keep them until the end. And if it happens for whatever reason that you want to remove them, do that by using RMAN commands, not using OS commands. So this M5 script is pretty new, so we keep updating it from month to month. So it's always important to download the latest version on the MOS node, okay? And finally, let's check some other best practices. It's with you, Roy.
Well, thanks, Rodrigo. Now that you've had an in-depth introduction into the tool that you're going to use and also an overview of the concepts in play, let's get dug in to the actual migration project itself. And like every migration project, the key to success is best practice before the migration itself. The first thing might sound very familiar to you. We want to advise you to be on the latest release update with the latest data pump bundle patch installed. Those are key components to a successful migration. To get that latest release update, go to the download assistant, which, as you can tell from the MOS note number ending in .2, it's not just a knowledge-based note. It will guide you to get the latest update for whatever platform you're on, whether that's a release update on something like Linux or AIX or the Windows bundle patch. Then you might want to look at other critical fixes that could be available for your platform and release update. Those will be in 5.55.1, which has the latest fixes, which might be going into, say, the next release update, or in our patches to consider note, depending on the different functional areas and components that you use in the database. And finally, just to re-emphasize the importance of that data pump bundle patch, it has both functional and performance fixes in it that will be vital to a successful migration. How vital is it? Well, consider this customer quote: just for doing an application migration, taking the time needed to migrate from over 2.5 hours down to 48 minutes. That's the kind of important performance fixes that you will find in the data pump bundle patch, depending on your configuration, the number of objects in the database, and so on. It's also important for performance purposes to have accurate dictionary statistics. Data pump is in some ways like an application whose application schema is your system table spaces, because we're querying tab dollar, source dollar, all of those system tables. And gathering those dictionary statistics is thus vital for getting good export performance and eventually good import performance. When do you gather them? Well, whenever seems reasonable, but we'd like to see them within a week of a migration so that they're reasonably accurate. That will give you the best performance for your data pump queries and for your migration. And then you want to gather those dictionary and fixed object statistics again after the migration, because you will have uploaded lots of information into that data dictionary. And if you don't have good statistics there, your application performance will suffer. The difference here is that after the import, you want to gather dictionary statistics right away, but you want to wait a little bit to gather those fixed object statistics until everything on the system is warmed up. Because a lot of those system tables that underlie the views, like $session, for example, $SQL, those are reflecting the current state of your database. And if you do it on an idle database, then something like $session will have practically nothing in it. So in order to gather your dictionary statistics, you could use DBMS stats, gather dictionary stats. Frankly, we find it better to gather schema stats on system and sys, because we have found some cases, and it's not consistent by any means, but there are some cases where gathering dictionary stats seems to leave behind a couple of important objects here or there that just don't have updated stats on them. The effect of gathering those dictionary stats, again, you can find it in data pump. You can also see it in your upgrades and other metadata intensive kind of operations. In this case, export going from 46 minutes to 8 minutes. That's a huge performance win just by gathering stats. And of course, gathering stats is an online operation. Another best practice for migrating a database is to think of it just like you're moving to a new house. Before you move, you want to clean out all those things that you didn't want to move to the new location anyway. You might have a bunch of things that have built up over the years, objects that apply to applications that are no longer in use, things that were built by people who retired 12 years ago. Whatever that is, clean up your database. The less data, less metadata you have, the faster the migration, the less downtime. So first of all, just take a stroll through your database and see whether you need that data and that metadata. Everything here matters, but for transportable tablespaces, metadata matters most, because remember, we're moving the data files as files. And even if you delete rows from a data file, the file itself is not going to shrink unless you do an actual shrink operation on the file. But if you can remove unneeded metadata, that will make the data pump export and import that much faster. So our experience shows that there are always things in a long-lived database that you can probably get rid of, clean up, and not have to migrate. So it's worth taking the time making the investment and getting to know what's actually there and what you actually need. The next step, best practice, is to execute a dictionary check. This used to be called health check, and there's a MOS note for the dictionary check script. What this will do is it will go through your dictionary looking for what we would call dictionary corruptions. Now, don't get overexcited about that term corruption. It doesn't mean like a corrupted block on disk or overwriting a buffer in memory. What it means is just something in the dictionary that shouldn't ought to be there or maybe doesn't reflect the current state of the dictionary. You can end up over the years for long-lived databases with things like indexes still there where the table that the index points to doesn't exist anymore. How does that happen? Well, there's a lot of reasons it might have happened in the past. And if you clean those up now, again, it's going to make your migration that much faster and cleaner. So here's an example of running the dictionary check script. It usually runs very, very quickly. And we're talking sub-second execution on even a complex system because it's just running a few dozen checks on your dictionary tables to make sure that everything is in good shape. And if it does find any violations, it will give you a reference as to how to address them. So this will produce that report. It will give you the findings that you can review. If you want to, you could use the repair option. Now, this script, I mentioned it's available for download from a MOS note. It's also part of the Autonomous Health Framework, which includes inclusion in ExaCheck and AuraCheck, and actually we're even including it in auto upgrade going forward. So that's making sure that your environment is clean and that you're going to move only what you want to move. But another good thing that you might want to do beforehand is just figure out how long is this thing going to take? Because I guarantee that somebody up the management chain is going to ask you, how long is this thing going to take? So the long pole in the tent there is often going to be that final incremental backup. It might be the metadata export and import as well. There's another way to test that. We'll talk about it. But the final incremental backup is one of those things that will govern your downtime. So how do you know how long that will take? Well, one way to do that is to estimate it based on your regular backups. If you're doing regular incremental backups, you can see how long those will take and then assume that that final incremental backup is not going to take any longer than that. Now, for a migration, you might actually rev up the backup frequency as you get towards that go live to reduce the size of that incremental backup as much as possible. So that could drastically reduce the amount of data that will be backed up in that last incremental backup. And remember, the last incremental backup is your downtime window. So if you compare those, you could end up with a much better situation than you have in your production backups. So one way to do this, on the final day, you're going to run several incremental backups. Your final incremental, you might even use a lot more channels. Why? Well, because remember that final incremental backup is while the table spaces are read-only and you have no other activity on your system. So that means you don't have to worry about using lots of parallelism impeding your application performance because your application won't be running. So you can speed up the backups, not just by decreasing the interval, but by applying more resources, more parallel channels. And here's a real life example. We had a customer whose normal incremental backup was down to 2 terabytes, and they were able to get that final incremental down to 951 gigabytes, so less than 1 terabyte. Or to take that from the highest level, here's the warning for you. Don't use your typical redo generation as the benchmark for how big your incremental backup is going to be. You might look at your database and say, well, looks like we're generating 3 terabytes of redo per hour. And if we take an incremental backup 1 hour before our go live period, that means our incremental will be 3 terabytes. Well, maybe not, because remember, even if you update the same block multiple times, every one of those updates is going to generate redo. But yet that block will only be present once in that incremental backup. So the redo generation rate is not necessarily a good yardstick for how big your final incremental is. Daily incremental is a better yardstick, and you may be able to improve on it with the intervals and applying more resources, more parallel channels. So now that's your prep work all laying the groundwork for a successful migration. Now let me hand you over to Daniel to talk about some of the things you want to do during the migration to get the least downtime and highest possibility of success. Take it away, Daniel.
Thank you, Roy, for holding our hands in the first part of the migration. But we have more best practices to share with you that applies during the migration. The first advice is that you should use blockchain tracking on the source database. This ensures that the level 1 backups will be much faster because RMAN does not need to fully scan the database. Especially for larger databases, it is paramount that you are using blockchain tracking, otherwise the level 1s will take too long. When you use the driver script to perform backups, for convenience, at the end of the operation, the script will print statistics from the RMAN operation. For instance, you can see the input bytes. This is the amount of data that RMAN had to read in order to produce the backup set. For a level 0 backup, you will need to fully scan the entire database, so input bytes will be more or less equal to the size of the database. But you should see that the level 1 backups needs to scan less data than this. You should see input bytes decreasing when you do the level 1 backups. If that's not the case, you need to worry. If input bytes matches more or less the database size, it is an indication that blockchain tracking is not being used by RMAN when you're doing level 1 backups. There could be multiple reasons for this. One of them relates to the way that change tracking works internally. When RMAN produces backups, for each of them, it'll put information about the backup into a bitmap. The bitmap can hold 8 backups. When you do the 9th backup, the first one is aged out. The migration backups needs to find information from the previous migration level 1 backup. But if you have done many level 1 incrementals for other use cases in between, there might not be enough room in the bitmap. You can increase the size of the bitmap. The default is 8. You could change it to 12 or 16 by using the underscore parameter. The situation with bitmap that gets under pressure can be worse in a data guard situation because the standby database will update the bitmap on the primary database. This ensures that when you switch over, the next level 1 doesn't need to fully scan the database. But the flip side is that all the backups from the standby database takes room in the bitmap on the primary database. You can turn this behavior off using a different underscore parameter. Which method suits your purpose? You need to determine. You can follow the must notes for more information. It's also very good to know that when you convert a standby database to snapshot standby, the blockchain tracking information is reset. So the next level 1 backup will need to fully scan the database. For the production migration, this is not an issue. But when you do test migrations, you can do those from a snapshot standby database, so we don't interrupt the business on the primary. But when you do that, when you convert to snapshot standby to make a test of the final level 1 incremental backup, you will see that it takes longer because the bitmap has been reset and we need to full scan the database even for a level 1 backup. For production migration, don't worry, but be aware of this for your test migrations. And also, if you plan on backing up from the standby database on the source side, if you have blockchain tracking and you do it on a standby database, you must have a license for Active Data Guard. If you don't have that license, don't use blockchain tracking on your standby database. The next advice I can give you is about statistics. We always need to have fun with statistics. Our recommendation is when you do the data pump metadata export is that you exclude statistics, and we will find other means of getting good statistics into the target database. Excluding statistics in data pump is also the default behavior of the M5 script. But we need to understand exactly what does it mean when we exclude statistics in DataPump. There are actually 4 things that you exclude by using this setting. First, we have table and index statistics, number of rows, number of leaf blocks, number of distinct values, and so forth. We exclude this information, but we know the optimizer must have it. So what can we do in the target database? One of the options is to regather statistics. You can use the DBMS stats package and gather database statistics. But for a huge database, this takes a while and it can be resource intensive. Even if you go warp speed by using concurrency and order degree during stats gathering, it can still take too long to fit into your maintenance window. That's why we have the second option, which is to take the statistics from the source database and transfer it into the target database. But we don't use DataPump for that because the DBMS stats package is a much better interface. It's much faster than using DataPump. We use the DBMS stats package and we put the statistics into a staging table, which we can then later on load into the target database. It has several advantages, including that we can import statistics in parallel to make it faster on the target database. We can also export statistics from the source database in advance of the maintenance window, so we don't have to do it while we have that precious downtime. You can simply export 1 or 2 hours before the maintenance window begins, and you save a few minutes during the outage. Oh dear. If you want to transport statistics, you might find a pitfall, and I know Mike has found this pitfall. So, Mike, can you take it from here?
Pitfalls? Did Daniel say pitfalls? Maybe. Let us explain what we have encountered with a customer we will speak later on about in more detail. We wanted to export the statistics and transport them with a stats table from the source to the target. That's normal. We do this quite often. But in this case, exporting the stats into the stats table took several hours. So we started a diagnosis and we found out the reason is extremely long-running queries going on 2 underlying structures in the dictionary, exp stat $, and exp obj $. Now this exp in the name start sounds like it has to do with exporting the statistics, but no, it has to do with expression statistics. You have not heard of expression statistics yet? That is expected because they are mainly used for auto-indexing. And not many of you use auto-indexing, neither did the customer. So we found a Moz node. The Moz node explains it here on the bottom of the slide. It explains how to clean up the statistics, but it gives also a warning saying, if you clean up, you need a specific fix in your environment. Otherwise, after cleanup, you will receive an ORA600. We checked the bug number. The fix is included since 1912. The customer had 1918, so no problem at all. Customer cleaned up and hit the ORA600. Why that? Reason is the fix is included, but optimizer fixes which may change behavior are disabled in our use. So unless you set them with DBMS Optim bundle and get a very long fix control setting in your SP file, the fix is present, but it's not enabled. So our task was to enable the fix. As you see here with DBMS Optim bundle, set fix control, we enable that specific fix. And this call will also make sure that other fix control settings will persist. We don't overwrite them. And then you can export.
The next thing that we must talk about is statistics preferences. You can define statistics preferences on tables, and it helps the database determine how it should calculate statistics for a given object. For instance, you can use table cast blocks to influence how the clustering factor is calculated for a specific table. But there are many other properties that you can set which influences how statistics are gathered. You can have statistics preferences on a global level. This applies to all objects in the database. If you're using global statistics preferences, you must manually set the same preferences in the target database. There is no way to transfer those preferences from the source database. But in contrast, if you have statistics preferences on a table level, you can use a procedure in the DBMS stats package to transport those preferences from the source to the target database. But don't just blindly copy all the preferences from the source database into the target database. Typically, you use statistics preferences to solve a particular problem. That problem on your old source platform might not be a problem on the new and shiny platform that you just bought. If it is an Exadata database machine with a superior storage system, you might not have the same problem at all. So when you are testing the new platform, see if those statistics preferences are actually still needed on the target platform. The final thing that you exclude when you exclude statistics is column usage information. Column usage information is something that the database gathers underneath the hood. It is information about how you use data in your database, how you join and which predicate that you use. The database can later on use this information to determine on which columns a histogram might be a good idea. When you set method op to something with size auto, the column usage information determines whether histograms are needed or not. If you don't have column usage information, well, no histograms are created, and for some workloads, it makes it impossible for the optimizer to come up with a good plan. Internally, we store this information in a table called call usage $. If you decide to regather statistics and you don't have column usage information, you need to be careful because you will end up in a situation with few or no histograms at all. And depending on your specific data, your workload, that might be a disaster. So if you decide to regather statistics, I suggest that you follow this plan. I recommend that you exclude statistics, and a consequence is that call usage table is empty in the target database. The database has no information on how you join table. So when you gather statistics for the first time only in your target database, don't use size auto because that means no histograms. Use the method op skew only. The database will look at the data distribution in the column. If there's a huge data skew, then it'll create histograms. This ensures that you will get histograms on the columns with data skew. Then you can go live. The users can start to use the database. They will join, they will use predicates, and now column usage information is updated in the target database. And then the following weekend, when the maintenance window open, well, then you can regather statistics with size auto and let the database determine based on the column usage information where histograms are needed. I would use this approach if you decide to regather statistics. If you are transferring statistics from the source database to the target database, you don't need to worry about this. If you find all this about statistics to be too cumbersome, you can decide to include statistics in the data pump export. The consequence is that the export and import of metadata will take longer because we need to handle statistics as well. But it might be easier if you use include equals statistics. Data pump will bring over all the stuff that we just talked about, except for global statistics preferences. But I must emphasize, we recommend that you exclude statistics in data pump and use some of the other means of moving statistics. That is it about statistics for today. I need a break, so I'll hand it over to the next one.
Thank you, Daniel. Now, talking about the agnostic, it's always important to have these two parameters set whenever you use data pump. The metrics equal to yes and load time equal to all. This will give you much more information about what is going on with your export or import process. And by the way, I really wish those values were the default for those parameters. All right, so data pump parallelism. Starting in 21C, we can run transportable tablespaces with parallelism for the export and the import. And it's very easy to enable that. You simply provide parallel equal to something on your xPDP or impdp command when it's running for transportable. But again, unfortunately, that's only a 21C onwards feature. So you can run that, for example, on the new 23C, but not on the 19C. We tried to backport it, but it was so complex and required so many changes on the code that we prefer to have it more robust starting on 21C. The good news is that the parallelism in transportable, they are independently on the import and the export. Meaning, for example, you can export from 19C with parallel equal to 1, and the import in the 23C with parallel equal to 32 or 16 or whatever value you want. Okay, so they are totally independent. If you run, for example, export with parallelism equal to 10, you don't need to run an import with this same parallelism. They are totally independent. Here is an example and a benchmark we had with EBS with 600,000 objects. And without parallelism, it ran in about 9 hours. But when we enabled parallel equal to 16 for both the export and import, we reduced it to 2 hours and 30 minutes, about 30% of the total time it had without parallelism. So we see here how parallelism can improve and reduce our migration window. So how is the architecture of parallelism when it comes to transportable tablespaces? So for the export, each worker, meaning when you run parallelism, you will have multiple workers. Each worker will handle a different object path, meaning one worker, for example, will take care of the tables, another one from the indexes, another one for the PillCircle objects, another one will export the users, and so forth. So each worker will get a different object path. But for the import, it's different. We cannot have this working on the import because, for example, we cannot create indexes before we create the tables. So for the import, multiple workers will work on the same object path with parallelism and then create internal dependencies so we know that, for example, when a table finishes, we can start processing the index. So data pump uses advanced querying, and advanced query uses streams, stream pool. So it's very important to size your stream pool buffer because that way you won't have the SGA resizing it during the execution, so you won't run in any performance issue of SGA during the export or import process. We recommend you to have at least 512 megabytes. This is usually sufficient for most of the export and import for transportable. Also, always disable the resource manager during the migration. You don't need it on the final export and on the first import you are moving this database. So disable it, and then you can re-enable it after you finish your migration. So if you have resource manager enabled, it might cap your CPU or IO utilization, even if you run your export or import with CISO system. So it's very important to disable it. How do you disable it? You simply run alter system set resource manager plan equal to this empty string. Okay, so again, always disable resource manager plan. And it's also important to disable the maintenance window before the export or the import. And why? Because this maintenance window may also change the resource manager plan. As I just showed, we don't want any resource manager plan kick in. And it might also gather some statistics on the sys and system schema for the internal objects. And we don't want anything running together with our export or import, because this may impact the performance. How we do that? First, you can query the window name and finally use the mess scheduler to disable all of them. All right. Never run export or import with sys as sysdba. We recommend you to use system, or even better, create a specific user for that and grant this user the exp full database and imp full database roles. That way, this user will be a specific user for running your export and import operation. Starting in 21C, the transportable jobs are restartable. Okay, what does that mean? That if you have any problem during the export or import, it's resumable. You can start from the point that it stopped. Okay. However, for 19C, for example, where most of the migrations are happening now, this still doesn't exist, this feature. So if you have any problem, for example, on the import, it's very important to have the guarantee restore points. So you go back to that GRP and then you can retry your import process. All right, best practice again, always practice a lot. Practice, right? Start with a very small system, refine your script, your migration workflow, and then move to a medium size and finally the large production database. Always try to automate whenever possible to avoid human errors, and create cleanup procedures to fall back and roll back, and also to retry your process. So you don't want, if a problem occurs, to have to build your fallback or rollback. So create those processes, make them ready, and also try them multiple times during your test window. And after the migration, always ensure to shut down the source database. You don't want your users connecting to the wrong database, right? Your source database is gone, stop it, keep it shut down, so that way you ensure all the connections are coming to the correct and new target database. And finally, keep the backups on the target databases until a new level 0 backup completes. So let's see that in a timeline. So first you create your new empty database and you create an initial level 0 backup on it. This will be very fast, right? Because this database is still empty. But then you start moving with your M5 script, the new data files inside this database. Finally, you run the data pump to plug in all those data files and do the final import. And now you start a new level 0 backup on this new system. However, as you're with many new data files there, this level 0 may take a long time. So you don't want to wait until it finishes to go live. So you go live before it finishes. And then the level 0 backup ends sometime later in the future. However, if any problem happens between the go live and the end of this new level 0 backup, you will need your M5 backups to restore and recover your database and to be able to recover it until the point of failure. So that's why it's very important to keep the M5 backups, the level 0, level 1s, and level 1 final until this new level 0 backup finishes. Now it's with you, Alex.
Thanks, Rodrigo. So let's see some advanced scenarios. You can use your zero data loss recovery appliance as the staging platform for your migration. One important thing to do is use the latest version of librA.so. So go to this mouse node, get the latest version, and update it on the source, on the target, and on your recovery appliance. Also consider to install the migration backup. So it's good to have a separate backup from your regular backups and your backups for the migration. The recovery appliance throttles the number of channels based on the appliance size. So if you have a powerful machine on your source and on your target and you are using a lot of channels, maybe the recovery appliance will throttle down the number of channels. So it usually uses the 64 channels. Another good thing to do is taking backups on your standby database so you can offload all the work from primary to the standby. How it works, we have your source primary, your source standby, and then you do the backup on the standby. For the M5 driver script, we have one parameter. It's backup from standby. You can set to 1 for test. So in every migration, we recommend you to test everything before. How it works. For the real migration, you do the level 0 and level 1 backups connected to the standby, and the final level 1 backup you will connect to the primary database. For the test migration, when this parameter is set to 1, the final level 1 backup will be done also on the standby, but the script will convert the standby to a snapshot standby and do the backups. Another thing to consider is to build the target standby as part of the migration, so you protect the target database immediately after the migration. So you have your source database, your target primary, and your target standby. You take one backup on your source database, and you restore to both the target and the target standby. So you have the tablespace at the same SCN, but it's not plugged yet. When you run the data pump full transportable export import, it will plug these tablespaces in your target primary database. And using redo logs, it will also plug these tablespaces in your target standby. But as you can see, when you are using OMF, you can have different names for the data files. The tablespace plugin process, it is expected when you plugin propagates to standby using redo logs, it expects to have this identical path and name on the standby. But since you don't have it, you have some options. So one option is use ASM alias for this, or you can rename the standby data files after the plugin failure. So it's now your turn, Mike.
Thank you, Alex. Now we have a few things where we would like to recommend you paying a little bit more attention. And the first one we would like to talk about is advanced queuing. Now we know that many of you may use advanced queuing, and with the migration with full transportable export import, there's no big deal with advanced queuing except for that you should be aware of one thing, and you must do another task after the migration. Now, at first, when you use advanced queuing, the database builds up structures by itself in the database. Let us have a closer look. This is in the source database. So you created a queue table, and in the background, the database creates a queue infrastructure, which are IoTs. Now, when you migrate over, when you do a transportable tablespace migration, in the target database, the queue table will be created and also a part of the original infrastructure, because many of the things get created on demand by the database. So out of the box, when you run our comparison script, that may differ. And a second factor here plays into it. It depends also on the compatible setting when you created your auditing table originally. Let's say on the source side, I created this in a 11.2 database with compatible 11.2, and now I move to 19C and it gets recreated. And also depending on a compatible side, the infrastructure may differ. So when you run now a script or a program comparing before and after, be aware that for the advanced queuing infrastructure, this may differ. This is not a problem. It's not a mistake, a failure, or even a bug. It's by design. Just be aware of that. And we always recommend that you use the higher setting. You could also give a compatible setting to the individual queue when you recreate it, but there are way more capabilities in the newer releases with the newer compatible setting. And there's a very good Moz note out there explaining what happens to AQs when you export and import them. One thing you really must be aware of before you open the bottles of champagne celebrating your successful migration, you must restart the queues manually. So manually means with a script, please. not queue by queue by yourself. Data pump doesn't start them automatically. Now, this is also by design. You need to start them. So please put this into your runbook. Start the queues if you use advanced queuing. Then let us go to the next topic, and this is auditing. Now, many of you use auditing as well, whether it's traditional auditing or unified auditing. Of course, we hope that you use unified auditing because it's far more superior over traditional auditing. And by the way, traditional auditing will be desupported in 23C and get deprecated beforehand. So we will focus here mainly on unified auditing. But more or less everything we tell you in the next 2 minutes will apply to unified and traditional auditing, maybe with different procedures. So data pump moves not only the audit records, but also the auditing policies. That is good. But what data pump doesn't move is the auditing infrastructure, because your target database has already one. So all should be fine out of the box, and we should take care on a few things. First of all, if you use auditing, you may have accumulated a lot of audit records over time. The question is now, do you really need them in a new database? You go to a new database, maybe a new release, a new infrastructure, new hardware, everything is new. Do you need the old audit records? Of course, you should not just throw them away. There's a reason why you collected them. So the ideal procedure would be that you archive them. And when the slide says archiving the records, that basically means you create a table and you copy the existing audit records out of the audit trail into that table. And once this is done, you start a purge job with unified auditing, or in the case of traditional auditing, you would do a massive truncate on out dollar once you copy the records to a safe place. Now the question is, do you really want to carry them over? They are now in a regular table. They will be migrated within the table space, of course. But is that useful? Normally, you would export them, preserve them, put them on the side, and if they are needed later, you would import them back into the database, into the new database then afterwards. What is much, much better with unified auditing is you can have a separate auditing table space, and it's supported with a procedure to set the audit trail to a new location. If you remember in the old days of traditional auditing, that was often a big thing. Like, can I have a separate table space? Some MOS node said, yes, you can. And then there was another MOS node that said, yeah, but when you patch to that, then it's a problem. So you need to move it back. And it was never a clear statement whether this is fully end-to-end supported. Now, unified auditing is much easier, and we highly recommend that. Don't abuse your sysaux table space for audit records. Have a separate table space. One thing I want to point out here, when you actively audit in your database and you have already a separate table space, you can't transport that table space because the auditing option prevents you taking this table space read-only for a good reason. So in such cases, you must stop auditing with the migration before you take the table space read-only. But just still the best case is what we explained before, because your new environment has already an auditing infrastructure. When you migrate it over, it means that you have to move your records into the new infrastructure. It's not possible to move the auditing table space via transportable tablespace as a functional auditing table space. Of course, you can move the table space itself, but not as a functional auditing table space. That means you must move your records afterwards if you bring that table space over with your records or your structures. Data pump unloads the records into the dump file. That's something which should really put some alarm signs up for you in terms of you have a huge audit trail. If you have millions of records there, we highly recommend, as we explained before, archive them and then empty it, purge it. Otherwise, you will get a huge dump file because the audit records will be really unloaded, not the structure, the records. And then it will also extend your maintenance window. So best way is really archive them, purge them, and then move over without the ballast from the previous environment. Yeah, and then at some point, you tested everything and you think, oh, it looks great. Shall we approach it? But what happens? In the unlikely event of something going deeply wrong, what are our rollback or fallback options? If something goes wrong now before go live, that is not an issue. You had downtime, of course, for the tablespace read only, but your source environment is fully preserved. So that is not a problem. But what happens if you went live and something now goes deeply wrong a day later? Then you would reverse the process going back to source. It's, of course, extra downtime, but you don't lose any data or whatever. If you migrate it to a PDB, then you can use the same process again to go into a non-CDB. That's also possible. The only restriction or bigger constraint is when you combined the migration with an upgrade. So you started, let's say, as we did in previous examples, we started with 19 and we went to 23C directly. Then transportable tablespace works only equal or higher, but not to a lower version. So in this case, then we have to unload the data with data pump and use Golden Gate to bridge the downtime and keep the downtime as low as possible. Otherwise, I mean, you don't have to use Golden Gate, but then you unload your database and we assume the database is not small. So you need to take downtime into account in this case.
Although most data types are fully supported by transportable tablespaces, there are a few of them that might require some special handling. The first one that we're going to touch upon is binary XML. And to describe the issue, I'm going to use an example. I create a very simple table called cars. It has one column car data, which is a binary XML. As soon as I create this very simple table, I can see in the dictionary that we have the car data column, the XML type, but it is in fact a virtual column. Underneath the hood, to support the implementation of binary XML, there's also a blob. It is the blob that contains the compressed and encoded version, the binary version of the XML document. You can go ahead and look in your own database in the dictionary to find columns that are storing XML in the binary format. Those columns might be affected by the issue that we talk about today. Imagine I have an XML document, some car data. It's a very simple XML document. In the real world, you could have much more complicated XML document. I want to insert this document into the database. When I do that, the first thing that the database must do is to compress and encode the XML document in the text format into the binary format that we can efficiently store and access in the database. In order to do that, the database will generate tokens from the XML namespace and the XML tags. Those tokens are stored inside the dictionary in a central table, and then the encoded binary version of the XML document is stored in the cars table. So if I insert this very simple XML document and I select from the table my car data column, including the hidden column created by the database, I can see that the textual representation is in the car data column, but the blob contains something that appears to be hex values. Let's take a deeper look at that hex value. In the dictionary, in the XDB schema, you will find a table called $QN. This is where the database will store the tokens that are generated from the tags in the XML document. We can see, for instance, the cars tag has been converted into a token. The ID is 50B4, and we can actually see that that token is used in the encoded version, the compressed binary version of the XML document. The same applies to the car tag and for all other tags and namespaces in the XML document. Knowing this, we can say in the table we have the encoded binary version of the XML. But in order to understand that, we also need the tokens from the dictionary. Both are required to read and understand the XML data. So when you move data with transportable tablespaces, we are moving the data files. What about the stuff in the dictionary, the tokens? Good news is that Datapump takes care of that when you do full transportable export-import. It'll move the tokens from the source database into the target database so we can read and understand the XML document there as well. But what happens during import if the tokens from the source database are already in use in the target database? We cannot just override the tokens in the target database because that would potentially corrupt the existing XML documents in the target database. And the other way around, if we don't import the tokens, we don't understand the XML document. To overcome this situation, if you have token conflicts during the transportable import, the easiest solution is to move that specific table with a conventional Datapump export. When Datapump loads the table into the new database during a regular Datapump import, it'll re-encode the XML document and generate new tokens. There will be no conflicts. But for a very large table, this might not be efficient. You might not be able to do that within your agreed maintenance window. In that situation, we have another solution where we can prune the tokens from the target database if it is a completely brand new empty database. We can then reuse the tokens from the source database and do some re-encoding in the target database before we do the transportable import. The other data type that we must touch upon is types, and specifically types that are evolving and used in table definitions. Again, I'm going to use an example to illustrate what's actually going on. I have a very simple type called car info type. It has one attribute model. I then create a table called cars with an ID column and then a column of the car info type. I insert one value, 1, and then an instance of my type, and the model is Volvo V90. Now things change, and I need to add more attributes to my type. No worry, I issue an alter type command, and I add the horsepower attribute as well. Now we say that the type is evolving. We are changing it from the original definition. I then insert a new value to BMW 530i with some 250 horsepower. Using the not including table data option, I specify that the existing records in my cars table are not touched, so I won't update them to the new type definition. I can then move on and add another car, but before I do that, I must add another attribute called color. My Hyundai Sonata has 160 horsepower and it's black. Now when I go and select from the cars table, I find 3 rows, 1 Volvo V90, we have 2 the BMW and 3 the Hyundai. All 3 rows are created with a different type definition. In order to understand the records that we have in our table, we must be able to go to the dictionary where we have stored all the versions of the type. We can read the evolution and interpret the answer that we have stored in our table. Of course, when we moved that table space into another database, we must also have the type evolution so we can read and understand the previous version of the types. Again, full transportable export-import takes care of this for you. But in order to avoid data corruption, when we are moving data into a new database, we must be able to have the exact same type evolution in the target database. Otherwise, we cannot be sure that we can fully understand and interpret the data that are using different versions of a type. Due to implementation restrictions of types in the database, in some situations, it is not possible for Datapump to recreate the exact same type evolution. When you created the type originally, you issued a create type and then a multiple series of alter type commands. Datapump must execute the same commands in the same sequence in order to have the same evolution. If Datapump cannot do that, to avoid potential corruption, it'll throw an error during the transportable import and skip that table. In order to find tables that might pose a problem during a transportable import, you can go to the dictionary in the source database. You can use the type $table to find types that have evolved, types that has multiple versions. You can then join with debate tab columns to find tables and columns that are using that specific type. The records that you get from this result might pose a problem. We cannot say upfront, it depends. If you get the error during the transportable import, there are three potential solutions to the problem. The easiest solution is to move the table with a conventional data pump export, but again, for a large table, this might be very inconvenient. If you know the exact order of the create type and alter type commands, you can replay the same type evolution in the target database instead of having data pump to do that. If we have the same type evolution in the target database, everything will be fine. The third option is not always feasible. We can recreate the type in the source database without evolution. So instead of having a create type and many alter type commands, you can just create the type in its final state with one create type statement, avoiding the evolution. But since you have dependent tables using that type, this might not always be a feasible solution. Which solution should you use? It depends, as always in IT. Here is some information for those of you with Oracle eBusiness Suite. Bad news first. For now, Oracle has not certified the new M5 procedure together with Oracle eBusiness Suite. If you have a database that you must migrate today, you have to use the former v4 Perl script. But don't worry, the Perl script has been a trusted companion for us for many, many years, and we've done many successful migration using those scripts. One of the customers that have also used the v4 Perl script with success is Advania, an Icelandic tech company that takes care of business for many companies in Northern Europe. One of the databases that they had to migrate was running on a Spark M7 supercluster. It was an Oracle eBusiness Suite that they wanted to move to a brand new shiny Exadata cloud at customer. They were using Transportable Tablespaces and the v4 Perl script. Luckily, Advania is such a cool company that the source database was already running on a recent release update. We just had to add the data bundle patch on top, and all was fine. In the end, Advania managed to migrate the database in around 16 hours. It might sound like a lot, but those of you that are familiar with EBS databases knows that they are monster databases containing hundreds of thousands of objects, and it really does take a while to export and import with data pump, especially because there are no parallel capabilities for transportable jobs in 19C. Overall, the team at Advania managed to do the migration within the agreed maintenance window, including encrypting all the table spaces on the new clouded customer database machine. I asked the team at Advania which learnings they would like to share with you so your migration can be easier. The first is that you should test. It is a complex project and you need to get it right. And you can only do that by testing unrealistic data over and over again. You also need to take the different procedures for EBS migrations, put them into a common runbook, and customize it to your specific environment. Use the same runbook over and over again so you can continuously improve it. That way, your production migrations will be super easy. Also, the team at Advania could use AWR to identify bottlenecks in the data pump export and import. Some of those bottlenecks originated from objects that they were no longer needed. They could simply clean up the objects and the export and the import ran faster. And finally, since you need to redo the test over and over again, it's a good idea to create a skeleton target database that you can customize to your exact need. Make a clone or a backup so you can use it over and over again for all your tests and eventually for the production migration. Hopefully, using these advices, your migration will be easier. But speaking of testing, since we know that we have to do tests over and over again, it's good to know that Rodrigo has a few tricks up his sleeve that will make testing so much easier. Take it from here, Rodrigo.
Thank you, Daniel. Testing the migration. Why is it important? Especially for two reasons, right? One, to secure a job, and the second one, to ensure that the migration will go flawlessly during the final migration window of our production system. So we want to predict any possible error that might occur, right? How we can do that? Let's take a look. So we can test the transportable export. How? We can provide this TTS closure check equal to test mode. And when we provide this parameter to data pump, it will not check if the table spaces are in read-only mode. So we can try the export without interfering in our production database, just maybe to measure the time or to see if any error would happen during the export. And for the import, we also have a parameter. We have this transportable equal to keep read only. And this will prevent the data files to be touched when we plug them in. So that way we can still reuse the same data files to apply the new level 1 backups that we are taking from our source system. Let's see some more details about those two parameters. So going back to the export, we can test data pump without setting the data files and the table space in read-only mode using this TTS closure check equal to test. So that only tells data pump to totally ignore that check, but of course that because of that, this dump file that's generated is totally useless. This is only useful for testing the process and measuring the time and checking the logs for any possible errors, because this will be exactly the same data pump export command that you will run on your final migration. The only difference is that on the final migration, it's gonna check for the table spaces and data files if they are in read only, okay? So that's very useful for testing the export. And for testing the import, we can use this flag for keeping in read only mode, the transportable equal to keep read only. So that way we can plug in the data files that are placed on the destination server without changing them, because we are not updating their headers. They are kept in read only. And that way we can still use those data files for the new level 1 incrementals that we are taking and applying on those data files. Let's see that on a timeline, how we could use this feature. Okay, so here I have my source and target systems. First thing I do is I take a level 0 backup in my source system and the full export for transportable on it. In my destination server, what I do is I create a GRP on my database. So that way I can flash back later to this point after trying my changes. I move that backup, level 0 backup that I took on the source. I restore and recover the data files, and I do the impdp for transportable in that destination server. After I do my tries, I can flash back this database back to the GRP that I took before. But what you need to notice here is that my user01 data file and data01 data file, they are the same as before because I used that transportable equal to keep read-only flag. So that means that after I take a new level 1 backup in my source system and I produce a new full export for transportable, I can apply this level 1 incremental over that data files because they were not opened in read-write, meaning they are still the same. And I can retry the impdp operation in my destination server and again and again and try again. And that way I can check how my destination server will behave after receiving those data files and that data pump full transportable export. However, to take this full transportable export in the source database, I need to put the table spaces in read-only mode. We saw that flag that we could potentially give, but this flag to skip the check would give me a useless dump file. So I cannot use that to try the import on the destination server. So what I need to do here is put my source system in read-only mode before running that. But that's not something easy to do in a production system. So a workaround for that is using a physical standby database for the full transportable export testing. How you do that? You get your physical standby database, you take the level 0 and level 1 backups from there. And to test, what you do, you convert it to a snapshot standby, you bring your table spaces to read-only mode, and then you run there your full transportable export. And then you use that full transportable export to import on the destination database. Okay? And you can try that multiple times. Another thing that's very cool to try and very useful to check for any problem, potential problem that would occur when you import all the metadata in your target system is using a regular data pump full metadata export. That's not a transportable export, that's just a full export, but only of the metadata. And why that? Because then you can get everything from the database, try the import on that destination database. You can, of course, after that, just flash back to undo all these changes, but just to check if you would get any error during the import of all the metadata of the source database. Now, Mike will show a very complex and amazing case we had with a customer. It's with you, Mike.
Thank you, Rodrigo. Now let's discuss some real-world example. Migrating the beast. The customer we speak about here is called Entain. Entain is not only one of the largest sports betting and online gambling companies in the world, they're also part of the FTSE 100 index. And you may know some of their brands like Beat It Win or Ladbrokes, Coral, Party Poker, Sporting Bet, and many, many more. More than 30 brands in the world are part of Entain. And of course, they have a highly demanding business and very, very active environments. Let us discuss at first what the constraints and challenges of this very special migration were. So at first, it looks very simple. We have a supercluster environment, and we told you before, supercluster is going out of hardware maintenance in June 2024. So there was some push here. Then we have a new Exadata environment, X9M Extreme Flash, and the customer early decided that they need a migration vehicle and ordered a zero data loss recovery appliance for this cross-platform, cross-NDNS migration. Now, this doesn't look that challenging, but we speak about 20 databases and the biggest database about 180 terabyte in size. Now you would say, hey, 180 tera? Okay, it's big, but not that big, but we have also 15 terabyte redo a day. And that's a lot. And plus, to make things a bit more challenging and complex, we have 5 physical standbys for the beast, for the big one, and 2 of them run locally, and 3 of us run remotely in a distant data center 2,500 kilometers away. This is the setup, and what do we want to do with the migration? The customer early enough found out, decided, came to the point that only full transportable export import can do that. Golden Gate, typical approach here to say, oh, we decreased the downtime, won't likely be able to sync 15 terabyte redo in average per day, and data pump would have simply taken too long. This is how it looks like. We have data center 1, and we get a new data center 2, not that far away from data center 1. The remote data center, the old, I called it data center far away here, is approximately 2,500 kilometers away. And in the production data center, we are on an M8 supercluster. And in the standby data center, an M7 supercluster. You see production on the M8. In the data center 1 with 2 local standbys, we have 3 remote standbys. Everything needs to be migrated. So we get the new Exadata setup here. Exadata X9M Extreme Flash in the data center 1. We have another Exadata, a PCA, and other things in the data center 2, and the recovery appliance to be set up. Technique here, Once the production database is set up, migration with the full transportable export import technique using the M5 scripts. Initially, we started with the V4 scripts, and at some point it was clear that we can migrate successfully all the databases, but not in the downtime the customer wanted to have for the large systems. For the smaller systems, all would have been nicely set up this way, but for the big environments, we needed something special, and this is where Jony and team developed the M5 scripts. So it had been used, and this is not the only customer where we used it already. So M5 scripts, restoring the backups not only to the production, but also to the local standbys, and on the same time also to the distant standbys in data center 2. So every backup gets now restored into 6 different locations. And once the full transportable export import gets imported, then it will be imported from production to production and then replicated via redo apply with all changes, all transactions, plug in the table spaces and such to all the standbys as well. Once we are done, we can take out the old supercluster environment and then also decommission everything in the remote data center. That is the plan. That is what we approached. And we did this here with the help of the new M5 scripts. So we have the Spark supercluster, and 2 databases play a role, the production and one of the local standbys. We have the recovery appliance and we have the new Exadata. So we deploy the M5 scripts, we configure them, and we deploy also the libraso, the lib we need on all the nodes participating in the migration, including the recovery appliance. Then we take the level 0 backup and we take this from the local standby, restore, recover, and then we start with the level 1 incremental backups after a while. And we don't take just one, we had several rounds of level 1 incremental backups. And of course, they all need to be restored and merged also on all the standby sites. So it's not just the production you see here. Then production outage, we stop everything, nobody can connect. And then we take the final level 1 backup from the standby again. But we take at the same time the full transportable export from the production database. And once this is done, we ship it over and we import it into the production site, and then all the changes get via redo applied to all the 5 standbys as well. Once we are done, we can shut down the old environment and then we are done. So this is what we showed you before also as process, and we did exactly that in this case here. Now, on PowerPoint, that looks simple, easy, doesn't it? I know. So let's discuss what happened in the background. What were the success factors? How did it start? The project timeline. So the customer in late 2020 already came to the point what they wanted to do. And then in 2021, they started the proof of concept for the hardware, the Exadata hardware. At some point, the hardware got ordered, then it got delivered. And we got involved into the project in May 2022. Information exchange, we went on site, we discussed this and that, and the customer often said, yeah, we tried that out, but it doesn't work, or no, it's too slow for us. So it became pretty quickly clear that this is the most demanding project we ever got involved with. In October 2022, the Exadata and the recovery appliance all then was finally set up and ready to fly, so we could leave the sandbox testing environments and start with the real migration tests. But since the customer used the most complex data types we have ever seen, everything used evolved object types, XML binaries, you name it, we hit also some issues we have not seen before. So we hit bugs, and it took a while to get the fixes. In December 2022, the customer did a mild escalation, a friendly escalation, I would call it, saying, hey, guys, we need to do better here. But in April 2023, it started really boiling up hot, and it became an executive escalation, which means then some executives at Oracle are involved and executives on the customer side are involved. You have many escalation calls and lots of reporting going on in the background. And it was not only about the migration itself. I have to confess. There were also other things, like we had an important standby. It was hanging back at peak days, I think 38 days behind the production, but it was needed for reporting. So this really introduced a lot of, I would say, challenges. Good thing is, at some point we overcame the challenges, standby were in sync, bugs were fixed, delivered, and then we could start a stress testing. And once the stress testing was done, the hot phase, the go live phase, started actually with a real dry run on October 3rd. So real dry run means we get production outage. We stop the production for 2 hours to set our table spaces into read-only mode and exercise the entire migration end to end. Trust me, this was the most important thing of the entire project. Having a good run book, but also doing a real dry run. Because we still found things to optimize. We still found one or the other tiny little piece where we had to fix something. So we could experiment and see how it really would perform. October 17th, 2023, all the migrations were then done. Everything happened nicely and happy ever after. One thing very important here, because when a project runs over such a long time, it's also important to understand where we started database release-wise and what we added. So we, of course, added also some one-off fixes, but we started with 1912. And at some point, it became clear that we need fixes in a data pump bundle patch. It took a while until we really discovered all the things. So with 1918, we were finally at a point where we said, now everything is there. Every fix we need is in shape, is included in data pump bundle patch, or is available as a separate merge patch for the environment, and we can go live with. And this is what we did. We went live with 1918. So let me show you I would say, the absolute key to success here. And this is a detailed runbook. On the gray bar, you see all the items in case you want to build up your own runbook. And we had over 200 individual tasks. That means it was clear when we start, what we do, who is the owner, who is the backup person, and whatever. And also taking down the real timings when you exercise it. And we could optimize this with the dry run we did on October 3rd. So we had I would say, super solid run book for the live migration, and we followed that strictly step by step. So what happened then in the night of the nights? We started with some pre-tasks at 10 p.m., some stats collection, AWR export, and some other tasks which needed to be done as a pre-thing for the downtime. And at 10:45, we basically put up the splash screens for the applications. Nobody could connect anymore, and the real downtime that could start at 11. First task then, in the source database, before we initiate the migration, we export the audit records. We needed them, we wanted to keep them, and then we truncated the audit table. Otherwise, that would have been all in the migration case and we needed to speed up the migration. Then at midnight, we set the table spaces read-only. This took about 10 or 12 minutes. And then the final level 0 backup could have been taken. And at the same time, in parallel, we started the full transportable export. So final level 1 taken on the standby, full transportable export taken directly from production. Recovered, the final level 1 backup takes 30 minutes approximately, and then also recovered on all the standby sites. And then the full transportable import got started, which took 165 minutes, 2 hours 45. After the import completed successfully, we started collecting dictionary and fixed object statistics, and we imported the statistics. So each piece back to back took 30 minutes importing, 30 minutes dictionary and fixed object stats gathering, as we showed you before. And so the final all-together database outage for the migration was an awesome 5 hours, 17 minutes, end to end. But this is not the complete outage. We needed some extra time because we needed to do functional and internal tests, comparisons to make sure everything is really there. And so the entire outage took from 10:45 until 8 a.m. in the morning, 9 hours, 15 minutes for a 180 terabyte migration of an extremely active database and 5 standbys altogether. Then we were all set. Fantastic teamwork. Awesome people on the customer side, an awesome team. Great team on the Oracle side as well. Runbook is really key to success. Absolutely. But the dry run was the game changer. When you do a real dry run and you learn the final pieces and you can optimize it, then you have such a good feeling when you go into the live migration. This makes a huge difference for everybody involved in the project. And just in case something really goes wrong, Roy will explain you now how to monitor and troubleshoot. Roy, your turn from here.
Well, thanks for that example, Mike. I think it shows that even with all of the advancements we've made in automation and ease of use, a major migration going cross-endian of a critical database is still kind of a complex task. And that means that you're going to want a way to monitor progress and to troubleshoot anything that might arise that might throw a monkey wrench into the process. So let's talk about monitoring and troubleshooting and what tools you have available. First of all, with any data pump job, you can always attach to a running job to monitor it or even change the job characteristics. It's a pretty simple process. With an export or an import, when you start the export or import job, you'll see the job name at the very beginning of the output. Now, that name is actually the name of the control table for the job. And what you can then do is attach to that by using that exact syntax, attach and give the control table name in another window. And that allows you insight into the job as it's running. It allows you to do things like change the tracing level, monitor the parallelism, look at the progress and all of that. So it's a really useful tool at the data pump interactive command line. In addition, you could do other things like take a look at the alert log. A tail-F on the alert log will give you that constant update as to what's going on the system. So that's a good way to tell if your system looks like it might be hung, or maybe it's actually just doing a lot of work that isn't producing output. Data pump operations are monitored also by the $V session longops view. So if you're good at using that view to monitor your long-running operations, you can look there. And of course, if you have the tuning pack, you can use SQL monitoring. That's either diagnostics or tuning, or it might be included if you're in the cloud environment. That's included with a lot of the levels of, say, OCI cloud subscriptions that you might have. So check your licensing documents to see whether you have access to SQL monitoring. That's the best insight that you can get into individual long-running SQL statements. The M5 scripts themselves, in order to facilitate monitoring and troubleshooting, has added some basic tracing capabilities so that you don't have to know exactly how to enable them. One of them is the RMAN tracing. So for all of those level 0, level 1 incremental backups, you get the RMAN tracing built in if you're using the M5 script. And it will also allow you to enable data pump tracing. Data pump has a lot of different aspects to its tracing, whether you're tracing the worker, the metadata, the control process, extensibility, and in this case, the transportable or pluggable tablespace aspect to it. So you don't need to know all of the bit masks that are available and what they mean. Just know that if you enable the data pump tracing with the M5 script, it'll do the right thing for the process that you are following. Now, on top of that, general monitoring always applies. Being able to go back and get an AWR snapshot so that you can understand the performance that you're seeing or that you did see in a migration is super important for diagnosing any problems or for interacting with support. The first thing you'll want to do is to shrink the AWR snapshot interval down to 15 minutes. That way, if you do need to analyze any particular time period, you'll be able to hone in on exactly when something might have been slow or running for a very long time without getting a lot of noise from the rest of the operation. You could set SQL tracing if needed, but SQL tracing can be very verbose. It will create huge trace files on a large migration. So that's not something I would do by default for monitoring. But if you needed to troubleshoot it and maybe rerun a job and say what was going on here, why did it choose this particular query plan, or what was the SQL that was being executed, then SQL tracing is a good tool to have in your back pocket. Export, import, always have metrics equals yes and log time equal all, so that you'll get a good, robust information for the performance aspect of your migration. The metrics will tell you a lot of information about what each of your parallel worker processes was doing, and the log time will put a timestamp right down to the microsecond for every line in your data pump log file. And then finally, when you're done, you could restore your AWR snapshot intervals back to their original and take another snapshot right at the end of the job. And that way, again, you can analyze the job itself from start to finish, or any segment of it, any 15-minute slice, if you need to analyze that performance. Hopefully you won't have to submit an SR, because everything is going to go smoothly and quickly and everything will go as expected. But if you do need to interact with support, here's what you need to upload for the fastest turnaround on your SR and the quickest insights into performance or functionality. The data pump log file, because that will tell us all the information we need to know about the job, like what was the command used, what were the parameters, what version were you running, all of that good stuff. AWR reports, so that we can see what was the SQL running, taking up the most time, any wait events or anything like that. And then, of course, those trace files. If you've enabled the data pump tracing with the M5 script, you'll get a robust set of trace files that will help us really hone in on any particular problems that need to be diagnosed or triaged. So hopefully we won't need to do any of that, and everything will go smoothly, but the tools are there for you, and the M5 script makes it easy. Now I'll hand you back over to Mike for a few final words.
Thank you, Roy. And you made it. Just a few final words. A migration is not a pet project. Even though this sounds very, very obvious to everybody, of course, we just would like to emphasize here. As you've seen with the customer examples, this is something, especially when we talk about very large, very complex databases, or many of them, which usually is not done within a few weeks. It takes longer, it involves a lot of resources. So plan carefully upfront. Be realistic. Be aware that this is complex. Tell people about the complexity. Don't start with unrealistic promises like, oh, it can be all zero downtime and no problem at all. This usually is complex. And if you have extra demand, extra high requirements, there may be extra work to be done. Train. Now, when you face such migrations in the near future, download the M5 scripts, play with them. We will have a lab soon for Cloud World this year, and then you can experiment by yourself, but it's not that complex. You don't have to migrate cross-platform to use the scripts. You can also do this going from one environment to another one, just to try out and get an idea how the scripts work. Focus on the important things. That's also very important. And work as a team. Don't blame each other. Try to involve the application teams as well. And to be frank, this is something we haven't talked about yet, right? A migration is not successful unless the database performs acceptably, or I would say exceptionally well, after going live. This is no secret. We all know that. You know it as well. So in case you would like to take this now a step further, use our performance stability description. We have a full seminar on that. We have slides. You can watch the recording. And if you don't have enough of seminars now, just sign up for our next one, move to Oracle Database 23c, and move to the multi-tenant architecture, to the CDB architecture on May 16. 2 hours earlier than the one today. Sign up, scan the code, and we see you then soon in the seminar. If you need other topics, remember we have over 30 hours of virtual classroom seminars up there, and the one you attended right now will be available in a few days via our blogs and then in our YouTube channel as well. And the YouTube channel is the final hint we want to give today. Please subscribe to our YouTube channel. We don't advertise, we don't make money out of it. We just would like to share technical content with you. Over 300 videos, and every week, I think 2 new videos on our YouTube channel. No marketing, no buzzwords, simply tech stuff, being helpful, hopefully, to you on an everyday basis. With that, Roy, Daniel, Rodrigo, Alex, and myself would like to say thank you very much. Thank you for your time, and happy migrations, successful migrations, and we hope to see you soon again. Thank you.